Part 3. When I add them together, I'm going to add this entry, -1, with this entry right here, 4. So -1 plus 4, right there. And this will be my transformed thing, right? Here's T prime, here's R prime, and here's I prime. These will be my new triangle and their coordinate points. So -1 plus 4, 2 plus 4 for R prime, R prime's x, and 3 plus 4 for I prime's x. And the y's, 1 minus 5, -5 minus 5, and 2 minus 5. So that equals, and again, you should always have a 3 by 2 matrix here. -1 plus 4 is 3. Here, one sec. 2 plus 4 is 6. 3 plus 4 is 7. 1 minus 5 is -4. -5 minus 5 is -10. And 2 minus 5 is -3. So these are my coordinates, although they're not put in. Let's check that last one off. We put them into matrix form and solution matrix. Cool. So that step 5 could be put these back into coordinate form. So T prime looks like 3, -4. R prime looks like 6, -10. And I prime looks like 7, -3. So basically what I did was I took my original triangle, my original TRI, at this point, and that point. I shifted everything 4 units over and 5 units down, and so my new triangle would be somewhere down here. Now, I didn't ask you to draw it, but it would look somewhere down there, and these are the points right here. This is that image. T prime is in that location, R prime is in that location, I prime is in that location. Mathematically, a lot of people maybe might find this a little bit tedious and long, but this is a good way of representing it so you can see every single individual entry and make sure you're adding them all correctly. And it's a good segue into what you'll do in Algebra 2 Trig with a lot of other things. Okay, and finally we're going to do rotations off the grid. What I mean by that is we've used XY coordinate pairs before. Say we had a square here and we wanted to rotate it, and we got the square there, and well, I guess that's not perfect, and then we would plot the points and say, okay, well that was simple because we knew what points they'd go to. We matched the pattern. Now we'll do it without those points, and this time we're going to do it by finding the measure of the angle, and not so much finding its point in space, or using a compass to do whatever, based on the pre-image and the image. First of all, you want to verify that the transformation is isometric. So that's the adjective for isometry, that word you learned. And remember, isometry means that your pre-image and your image are congruent. So verify that the transformation is an isometry, that it is congruent to your pre-image. Okay? Discover and label corresponding congruent angles and segments. So if I had some triangle here and I rotated it down here, I want to match up my points. I want to say, okay, this point corresponds to this one, maybe this point corresponds to this one, and this point corresponds to this one. Normally they'll be named something like A, B, C, A prime, B prime, C prime, and make sure that you match them up. And the segments too. You can say, maybe this is AB, and that matches up with that right there, etc. So make sure you match them up. So where you label vertex A, label the corresponding congruent vertex A prime. Make sure you note that. Draw segments from corresponding angles to the fixed point and analyze the central angle. So let's say that my fixed point for this rotation, I know it's a little scruffy there, but let's say that here was my fixed point right there, and I wanted to rotate this down to here. Okay, so if I have, let's say I called this one B and B prime, I want to draw a segment from here to here and from here to here. And then I'm going to use that central angle and say, okay, how far did I travel there? How many degrees is that? Maybe it's like 120 or whatever it is. But drawing these two things actually shows how far I did rotate. So that's really what we're doing. Now with isometries, you only need to do this once. Like for instance, my A and A prime, if I did those right here, I drew segments. I wouldn't need to do it here because I already did it here, and we rotated the same amount each time. So these central angles should be congruent. So you only need to do it once. But be sure that you appropriately labeled your vertices. Make sure they're all appropriately labeled. So let's do an example here. Find the angle of rotation about point P. Okay, so make sure, let's see, verify the transformation is isometric. Is it isometric? Are these congruent? Yeah, it looks like they are, and normally it'll be pretty obvious if it's not. Go and check that off. Discover and label corresponding congruent angles and segments. Okay, so here I have B. Well, actually, here, let's start over here. So we have the slanted line right here. So this is probably the slanted line right here. So this is C prime, and this is D prime. And then I can match up C goes to B, so C prime goes to B prime, and B goes to A, so B prime goes to A prime. So I can match things up as well, make sure AD, A prime, D prime, etc. Okay, so there are my points. I'll go and mark some of them off. Okay, draw segments from corresponding angles to the fixed point and analyze the central angle. Okay, so you have to notice where it rotates about. I mean, I say it, but it rotates about point P. So here's my fixed point, and I have to mark up 2 segments from other points. Let's go ahead and do that. So I'll do it from B again. Actually, let's start from A. I'll do it from A again right here. So I'm drawing from A to the fixed point and the fixed point to A prime. Okay, I have to figure out what this central angle is. That central angle in this case is 90 degrees. So that's perfect. So I figured out that I rotated about point P 90 degrees, and was it clockwise or counterclockwise? Well, that's clockwise. 90 degrees clockwise. I could do it again. You know, I could do it with B, or here, let's go and do it with C. I could do it with C, for instance, but remember, we already did it with A, so we're okay. We don't have to do it twice. But just for good measure, I go C to here and P to C. Is this here 90 degrees? Yes, it is. So each thing rotates 90 degrees clockwise. Okay. Now, I can't do this with D, and that's the next point that I want to make here. You cannot use a set of corresponding vertices, this should say, that are on fixed point. That are on a fixed point, because there's nowhere to draw from. You know, if D is on this point, I can't draw a segment and see how far it rotated. And here's basically something you might want to write down or keep in mind. When rotating about a point and a vertex is on the fixed point, so D is on the fixed point here, it will end up being at the same place after the transformation. So for example, D is the same as D prime. That's the same as a reflection, right? When if I go way back here, if I go way back here to this first example right here, and we rotated, and we reflected across the x-axis, A and A prime, because they were on the axis of symmetry, they're going to end up being in the same place. So the same thing back here at the very end, D and D prime, when I rotated them, they're in the same place because they're on the fixed point that I'm transforming on. Okay, finally, in summary, here's your homework. You have these problems, not too many, and they're actually pretty straightforward, and they should be based on all this stuff. And if this stuff helped you today, complete any unfinished problems from Friday's homework assignment. So if there's something that you didn't know before, maybe you can now go back and finish it. And finally, we have a group quiz tomorrow. It's open notes, it's open book, you get your homework, and it's a group quiz, so you get to converse with other people and stuff. But keep in mind, this isn't just regurgitating these things, okay? I'm going to try and I can try and show you special things with some of these problems. You know the functions and you know the definitions. And if not, you can look them up in your notes and book and homework. And hopefully you can figure out how to solve some of these problems, converse with your group members and stuff like that. Okay, so hopefully all of that there makes sense. And hopefully this helped out. And I will see you in class when we try and do this quiz.